Version control. I will say I'm going to do this different from some of the other sections by necessity. If you saw in D2L that there's an outline for where we're supposed to be, we were actually supposed to get to, I think we're supposed to finish, where we're supposed to be. We're supposed to do development this week, which is well beyond version control and testing. Development, he calls it, his command line arguments, files and exceptions, including inheritance this week, and then after reading week. Well, the two people who are teaching actual lectures, quick story, I guess I need to get to why I'm teaching the way I am now. Professor Mahmoud's doing one, I'm doing two of them. Professor Hudson's coordinator, but he's not doing any lectures. But between Professor Mahmoud and myself, we said, you know, it's pretty, as I said in class, pretty darn hard to keep up with the outline he specified because there's so much to cover, unless, say, we skip stuff and it isn't good, or we cover it at a high level. So he was behind himself. He's not as far behind as I am. So the gist of the conversation we had was catch up almost at all costs in lecture. The other thing, I was preparing this stuff before the weekend, I saw a note with Professor Hudson to the TAs. He's coordinating TAs along with the head TA. He said, it is okay to, he said to TAs, it is okay for you to be ahead of lecture because in terms of version control and GIT, we will cover much more than we cover in lecture, which left me wondering, why am I behind? Why am I covering version control? And I am covering it. So what I'm going to cover now leads to why I'm covering this is not many of you have used a version control system. So you likely, a good portion of you, won't know what the point of it is. What's the value? How does it work? So that's my focus essentially. The concepts behind it, terminology, I'll explain it with some more hands-on examples. But the specific, how do you do this in GIT? I'll do a little bit of this. How do you do it with the online GIT? But the TAs, click here, click there, that's what they should be showing you. I have this set of notes, if you looked at them, they're huge. It's because at the very end of it, so you're not missing anything, it includes a copy paste that has a credit to Professor Hudson. That way you can look through it. I looked through the gist of it and I've included the major things, but I'm also going to let them know that in order to catch up, I had to whip through it and I didn't include all the concepts, and probably the same in testing. And if he includes it in the quiz, likely, then the TAs are going to have to cover essentially the stuff that's here. And he has another section with version control from Professor Steve Sutcliffe, which essentially is new examples of the same thing. So I will let him know where I'm at so he can tell and also coordinate for the quizzes. But if he's going to quiz on this stuff, because I'm trying to catch up, then he's got to rely on what the TAs are covering. So that for you, it is possible fair game that the quizzes could include something from tutorials that haven't been covered in lecture. So it's up to Professor Hudson to make sure when he looks at the quizzes to ensure that TAs actually have covered it. Okay, version control. What's a version control system? Because very few of you probably used it in class. There's 100-odd people that showed up and there's only about 6 hands. First, software always takes the form of different versions unless it's so small that you bang it out in one sitting in just say a couple of hours. That's not the way it works with real life software. If you think about software, say operating systems, iOS, the OS for phones, Apple phones, they have different versions. I think they're up to 16 or something. Different versions, they add new features. And they cut off, say, the iPhone 7 Plus at 15 or 14. Windows, Microsoft has different versions of the operating system. Operating system is software. It's special software, controls your device. They had Windows XP, and then they went to Windows 7, and forget some of the stuff in between here. Even with XP, they had incremental versions where you had software updates. So that process of creating versions is something that applies in real life. A version control system basically allows the development team to manage a project. The versions or the work itself is stored in something called a repository, a special form of, if you will, a database or storage area. It backs up the software, but it does far more version control than just backing it up. So with the CS GIT for the University of Calgary site, for instance, it is potentially a backup of your software. Although backing it up, uploading it to D2L is a little bit better because, as you see, it doesn't have it in a complete form in GIT. If you upload your individual classes in D2L, then you can just download the class that might be missing on your system. Okay, so the idea of how this works is, think of it this way. It's easiest to illustrate when I talk about the online version of the GIT, the CS GIT that you have to upload to. You will create a repository to store, even for your individual submissions, in CS GIT. You can create a local one as well too. And in fact, you actually have to create a local one, LinkedIn. Now, once you create this one, what you'll have to do is connect your local one on your computer in IntelliJ with this one. I go through some of the steps, but this is where the TA should go through all steps. I was going to include it all, but then I saw Professor Hudson. It's pretty extensive, and I got to catch up. Okay. Now, when you link these two, and I'll talk about the starting steps for doing this, when you actually want to upload your software to the CS GIT, the term is you are pushing it. And there's actually a feature, if you link it properly, a push feature inside IntelliJ, and it uploads it. And as you say you're working in a team now, it's easy to see the pull. You push something new, a new version of class, another person working on your other classes in your project, they can pull and download that version of your class. So there's that push-pull. Professor Hudson's note has these with some animations and diagrams where you can see the effect of these, but this, I've included the gist of what he's getting at. His might be visually easier to see, but then I've kind of animated my hands here. So you have snapshots of the software, the version control software. It manages the versions. It includes all these snapshots over time. When we've actually have pushed the initial version, then we push a new version. There's 2 snapshots. It keeps that because we might want to go back to a previous version. But this process of development isn't feature on top of feature on top of feature, linear, where it's one step has to precede the next step. Kind of like saying when you have a linear versus non-linear, good way to illustrate is a video game. If you have an adventure game, linear means, say you have rooms, it's almost like a list. You have to complete this room before you can go to this room, and then this room, and then this room. In a way, it's almost like room with one door that leads to the next one. That's an extreme case of linear adventures. Non-linear is where you have rooms and then you have doors, and you can, this is one example, non-linear, and you can complete the, not just go to different rooms as you choose, branch out in your direction of travel, but quests. You might complete one quest before another quest, although it might be harder to complete a second quest. This development isn't just linear, but you can actually branch out and try not branching in terms of ifs, but branching in terms of let's try implementing these features. And it doesn't have to be in the branching. It has to be a particular order, unless the code requires it. GIT doesn't require this. Many VCS systems. GIT is one. I've used CVS a long, long time ago. GIT's probably the most popular. Version control without a VCS, a formal one. So this one I introduced, covered in the other class. I use this just to illustrate a few things, the learning objectives. We'll get into it. One is, it's a very simple little software. Yes, it's so simple you probably wouldn't create versions. It's so simple you could bang it out yourself. Not in 231, but by this class, you should be able to bang it out fairly quickly. But it's small and simple to illustrate the concepts of version control, because I'm not assuming that you've used version control, you know anything about how things work. The other thing that I use this example for is, in the future, when you're working on your software projects, even if you find that using something formal like GIT is just too much overhead, you should manually make backups in different versions. Have a manual approach to version control. There's advantages. So one, I have this to illustrate the version control concepts with a very simple example. Two, the second learning objective is to show you, if you don't use a formal version control system in the future, you have to use GIT for this class and upload the GIT repository. But in the future, here's how you can do it. That's the learning objective from this exam. In the past, actually, Professor Hudson does this. So I'm not too sure why he has actually the practical part of version control systems and testing in the lecture notes. But he actually expects that the lecture won't be covering the specific details of, say, version control systems, how to use GIT, click here, click there. that's going to be covered in tutorial. And that's why, although I told you that you need to go to tutorial because they're covering things that we don't cover, because that's such an important part of your assignment, it's an integral part of the assignment. Using GIT, that's one thing. And also using JUnit for testing, I took sympathy and I had a reminder saying, make sure you go in tutorial. Now, with that in mind, however, Professor Hudson does have video that's posted in D2L, and I've got numerous links to it. It's complete enough, so it should show you how you can actually fulfill the GIT requirement for the assignment. It might need some additional things that they're covering in tutorial, because I also told Professor Hudson that both of us actually, both the lecturers aren't covering version control systems, GIT and JUnit all extensively, so you have to rely on tutorial. So I told him to keep that in mind for the quiz. So there's a video for the GIT. However, for the JUnit, there isn't any videos around. I asked him about it that are publicly available. There's one that's available that's just on the TA link that a previous TA made. So I just posted a query to the head TA who actually posted that. She got it. Is this available publicly? Will this person mind having it publicly available? It's not mandatory to have it because I asked some of the people in this morning's class, and they said, okay, based on what they've gone through with JUnit right now, they're able to get by without it, but I thought it might be handy. But it's not my video, so I can't post it myself. It's not polite. So if it's available, you'll see it there, but do make sure you're in tutorial. However, a lecture won't be useless, I hope not at least, because there's some important conceptual concepts associated with testing and with version control that should help you understand the application of these programs. Because the TAs, they might be going through stuff. Different TAs, there's not a fixed set of notes that TAs go through. So some of them might be going through just straight, here's where you click, without an explanation of how things are working. So in terms of the theory, the important theory of how things are work, I have an example to start off with the version control, which is manual version control, to help you understand, well, how does it work? Why would you bother with it? So version control without using a version control system. So doing this manually, I see we left off, we didn't cover this. I can go through this fairly quickly. It's a simple little program. In this case, I don't have source code. I could have posted all of it, but then your focus would have been probably on figuring out how the program works, which is not the learning lesson. It's a simple program. It's just using this program to illustrate version control, the process, and why bother doing it. So I kept it simple on purpose. I think there's text available, so you can actually copy paste the text, but it's not in a complete posted form in a web link. Now, this program is so simple that developers would straight out admit probably wouldn't bother version control. Maybe if this was a 231 assignment, some students might do it because, well, actually, as a 231 assignment, depending on when you got it, it would only be a little, what I call mini assignment, not one of the big assignments, but the little assignments, maybe worth a percent or so, to help you learn branching and looping. And you'll see why in a moment. If I had it as a mini assignment in 231, and it was earlier in the course, say about 4 weeks on, yeah, a good portion. I've had it actually, this type of assignment, and there's some students that it's a challenge. It's not straight out easy. Right now, it's pretty easy to do, so you probably wouldn't bother version control, but maybe those students would because they find it harder. So what does this program do? The gist of it is, I give you a hint here that it involves branching and looping. It is a program that prompts the user for a base and a power, and based on the base and with the base and the power, it calculates within the program, without using a library, the exponent. That base raises the power. How do exponents work? Essentially, reminder, it's repeated multiplication. 5 squared is 5 multiplied by 5 twice, and the number of times you multiply is the power. 2 cubed is 2, that's the base, and you multiply by itself 3 times. It's repeated multiplication, so that's where the loops come in. And you can use branches to figure out what if you have a power of 0, that's 1. If you have power 1, it's equal to the base. There's a solution, straight out, not hard at this point. Okay, fine. The program's not the key part of it. This is the requirements. I just described what it's supposed to do. But this is, again, the learning objective is to show version control manually to help illustrate how it works, as well as some of the concepts. So we have different versions of the program, pretending that we actually split into versions. So the first version is dead simple. What one should do is as they make a new version, a real version where it's actually challenging, they document what they've completed. Very nominal. All it does is user input. And then they make a backup of this. So suppose that this was called exponent.java. They'd make a backup copy of this file to say exponent version 1.java. That's actually something that I do here. Fine. Then we continue on adding new features. Now, in this case, the learning objective I'm trying to illustrate is branching in version control. Not branching in terms of ifs and case, but branching in terms of alternate courses of development, implementing things. So I'm simulating here, we have two people working on two different parts of the program. That's actually easier to visualize. There might be cases when there's two people that are working on it and there's some overlap. That's a little more complex. I'll talk about that. But in this case, these are two fully independent parts of the program. That's why I actually chose this. Version 2A is a branch where this program, after calc gets user input, it calculates the exponent. It asks, do you want to calculate again and again, repeatedly? So that's a loop. That's the main loop that controls execution. Version 2B, on the other hand, is actually more extensive, but it's one self-contained part where it does the meat of the program. In this case, it's a little bigger, fine. It's where we check, given that we got the base and the power, we figure out the result. So it does a repeated multiplication here. So version 2A. So here's the code for version 2A. Oh, it's a screenshot. Is it? Yeah, it's a screenshot, actually. Again, it's so simple that you could bang this out on your own. I don't normally do this. I might even put copy-pasted text. In this case, I didn't bother. So we have the main loop that continues on. We have, it runs at least one, so it's a do while, run again. And if the person answers yes or yes that they want to run, then it's true. But the run again by default is false. So if they enter anything but yes or yes, they're going to break out of end the program. So that's all this version does. So it shows this is building on where we get user input for the base, and it adds more user input. So it's further in development, but it's a side development. Version 2B, this is, well, it's not much bigger, but it's more complicated, where we actually do the calculation exponent, but it only does it once because the repetition of calculating exponent is in the other version. So after we get the base and the power, if it's less than 0, to simplify it, I didn't want you to look at code worrying about -1, so it assumes it's greater than 0. And it doesn't do any of these other parts where it displays 0 is kind of an error case. It doesn't calculate the exponent. Less than 0, my mistake. If it's 0, then it's just 1. If it's 1, then it's a base. And here's where it repeatedly multiplies. Fine. That's all you need to know for this part of it. But now we've got a separate branch of development. And again, we make up with version control manually. The idea is when you have a significant amount of the program completed, that's when you should make a new version and then document what you completed in the version. I may have said the other day, I said in the other lecture, I'm not sure in this lecture, I actually do this. I got in the habit of doing this as a student, making up backups like this, because potentially I have done this as a student where I've screwed up, where I've added a logic error, say in one of these versions, but unfortunately, logic error is so screwy that it actually broke the code for a previous version. Ideally, it would have been better for me if I had time in the ideal world to trace through and figure out where the error is and fix it. But I'm also pragmatic. I've got an assignment deadline due. So what I learned to do was the thing is, I couldn't just go back to a previous version necessarily, because eventually I was taking 4 computer science classes, just computer science, a semester, and then TAing as well too. So I'd be alternating working on classes. So I might work on this, and then work on something else, study for exam and so on. That's time management. Then I added this feature, I broke it, but I can't remember what I had in previous version. Then I have to basically hand trace that. I could do it, but it wasted time. What I learned to do was then I could say, in the previous version, it was a significant amount, then I could tell exactly where I left off. And presumably I tested and debugged it reasonably well. So I'm sure that this version is working. And then when I start implementing version 2, I build on this one. And I don't touch the backup so I don't accidentally screw it up. That's why I got in a habit. One reason, documenting very quickly what I completed in each version. But that actually follows industry practice. If you think about it, when you download updates, I don't think they do that for a phone, at least not for the iPhone that I recall, unless you probe for it. But in Windows, they can tell you with the updates, software updates, the operating system, what you're getting in the new version. So documenting features and bug fixes and security fixes in version is not only a good idea I got from my student days, but also done in practice in industry. If you use a formal version control system, such as GIT or something else, then that is standard practice as well too. So I'm using this version control system to back up the software, but it does more than that. It also indicates what I've completed for each version, a little bit more in backups. Now I have 2 branches, and one, if you think about this one contains the whole program, except for some variable declarations. Each time we go through this loop, we calculate an exponent. The calculation of exponent is done in another program. So we have to take these and merge them together. This is where doing this process of manually creating versions isn't so bad if it's just linear, step by step by step. And if I was just a student doing this, I do step by step. I'd probably make that main loop as version 2A, and then I'd actually build 2B on top of it. But when you're in a group, you divvy things up, and then you have to rejoin it. That's where having a formal version control system can actually help as opposed to manual systems. I come up with the final version 3, that combines the two, and this is just a pseudocode that includes the gist of it, not the whole thing. We have the main loop, and then this is version 2A, and then all this stuff is a simplified version of 2B. Now, what I actually have here, this is the manual version. This is what I did as a student. I don't do it with such a simple program. I do this sort of thing, even with the fairly simple assignments that I'd have for 231 and 233 when I'm the instructor. I'm making these solutions myself, not because they're devastatingly hard, but it still takes me a few hours to bang it out. And I kind of think, well, okay, yeah, if I lose my previous work, say 2 hours of work, yeah, I can reduplicate it, but why waste the time if something happens? So I back it up, and that way if something goes wrong, I actually delete it or something, it's available. So I actually do this for and even simple programs, but anything but not so trivial. So this location where I back it up, I call a repository. That includes your version information. Now, of course, in real life, when you're backing this up, don't do something stupid, and I've done this, where I just put them all in one directory or folder, and it'll properly back it up, because things could go wrong. And I've had that happen as well too. Notice this exponent example.java, it doesn't have all these suffixes. These are going to be problems because the file name has to match class name. So this is actually the current working version. And I basically, as I have a version, I copy, paste, make a version. Actually copy, not copy, paste, but copy an operating system. And I rename that copy of this. And I don't touch these ones. That way, if I bugger up this one, the current working one, I can go back to these ones. That's an important thing. But GIT essentially should have something that allows you to recreate these versions. A bit more on that later. Now, with the simple example, this isn't something that you should do for this class. This manual version is basically just showing you the value of the process of version control. So it includes backup and more, organizing your code, as well as including information about versions. When should you make a version? Your team might actually, your programming team you work for might have some rules of thumb, but I'd say the TAM rule of thumb is this: if you're working on something, it's going to vary from person to person. And you say, I've completed this assignment feature, saying, man, I'm glad I did it. This was a fair challenge. That's kind of a signal, because it's a fair challenge for you to make a version. What in this case, you'd be making up a version for GIT and then pushing it onto the GIT server. What is significant for one person could be trivial for another. In a way, it's almost like, say, playing a video game. Play a video game, and you say, man, I'm glad I got through this one area of the adventure game. I had to play it over 12 times or something or whatnot. That's probably a clue that you should save at that point. Because yes, you solved it that time, but do you want to go over the rigmarole of doing it again if you die off later? So if you don't use a formal, if you find it's too much work to use a version control system, then at least do this manual system. So you have backups and you also have a managing of the backups. Again, don't do it for this class because you're required to use not only use Git, but have your code in the UC Git repository, but also as well as submitting through Dropbox. But this should give you some idea of how version control works and some value of it. But it isn't, although it's very simple to implement, it doesn't provide all the features of an actual version control software system. And that's what your requirements. Terminology. TAs, hopefully, explain these terms, but it doesn't hurt to hear it again because you frequently hear these terms and it might show up on a quiz. Repository is a location where you store all the versions of software. But typical version control systems, unlike with my example, don't actually store these in complete files like this. What they store is essentially what's called incremental changes. If you've actually used backup software on your computer, as opposed to, say, copy-pasting folders and directories to back it up, but you use formal backup software, the term they have is full backup, where essentially it's like this. You make a copy of the files and directory structure, or what they call incremental backup. Basically, from version to version, what they actually save, what they do is they save a starting version in complete form, and then say when we get to version 2A, we add that looping. The only thing they save in 2A version in the repository is basically the code that changes. So you don't include this stuff from version 1, but you just include that loop that repeats the whole program. That's called the incremental backup. Because in backup software, what they do is from when you ran backup last time, say a week ago, to now, a week later, the only thing that they back up to speed up the process is backup. It checks which files have changed. It's basically very similar to that. So your repository, you can't just download, copy, paste it, typically. It stores just the incremental changes. But within Git itself, it can have the base file as well as has the incremental changes, and it rebuilds essentially different versions for you. That's the thing to be aware of. And that's the change history. What modifications have you done? When you actually pull something properly, they call it pulling from the repository. It should give you that current version of, say, a class, however. If you don't understand the process of the incremental, here's one example that's for fairly non-technical people. Checking out, committing, updating. So the way Professor Hudson words it, he worded it so it looks like I'm putting this bracket explanation. Getting a local version at the very beginning, as opposed to later when we do this pulling. This is later. So this is at the very beginning. This is later as we have multiple versions. The committing part of it is essentially, I described the other day where we have that central repository on the UCalgary Git. Initially, it's empty. It's just a project. But when we actually get work done, that's where we commit it onto the server. It's easier to see the updating and the pulling when you're working with multiple people, because when you're working by yourself, you're working on your local repository in IntelliJ. Then you have UCalgary Git, and it's just you. So when you actually commit stuff, well, you're basically just committing what you have stored locally on your machine. So the pulling isn't something that you'd frequently do because you already have the latest version on your machine. Unless maybe you want to revert to an earlier version. You screwed up this version or you lost it, and then you want to pull the later version. But the pulling, the updating essentially is more common, easier to see, more commonly used if we're working in a team. If we have the Git repository, empty at first, and I'm working in a team here, 2 teams on either side. One person starts working on their class or classes, and they commit it here. They push it onto the project. This other person is working in your class or class, they committed over here. Well, now there's a new version here from this person's. Well, this guy will probably need a new version. So now he's going to update his version of the code with whatever this other person just updated. So it's easier to see the updating pulling when there's more than one person working on it. The branching. So in this case, I picked an easier to conceive case. It's just one person. but they're two completely independent parts of the program. They're related in that one contains the other, but changes in one don't affect changes in the other. The term is they're decoupled. Changes, that's what it means. Changes to one don't affect the other. The coupling means how changes in one part affect another. If they're tightly coupled, then say you have global variables, that could make it tightly coupled. I change a global here, which can change something here, which is why globals are rather on the bad side. Fine. Moving, just keep an eye on the clock. I'm purposely not putting this full screen mode because it results in some problems. I missed some stuff I have to go back to in class. So sometimes people people would be working on different parts, but there'll be some overlap where there's some conflicts between what they're changing. I'm working part here, I'm working part here, but they're affecting a common section. You can't avoid that decoupling. If I change that common section, what happens here? Well, there's different ways of handling it. We have version control system. And Professor Hudson lists two, but actually thought of a third one that's possible. One is the simplest approach to implement, but not necessarily the best. Locking. If I am working on that one part, that common part, then it's essentially locking that file so no one else can check it out. No one else can edit it till I'm done, and I say I unlock it essentially. It's almost like me, I think you've seen in lecture a few times, when I try and pull up a file, it says it's locked for editing, the PowerPoint. It's because I'm using my work account, and then I have my own personal account, and in my personal account, I'm skimming over stuff. So say I open up a Java file with my personal account. I didn't log out, but I switched to this work account, and I forgot I was logged in here, and it says I can't open it for writing because it's locked. Another approach, the GIT approach, works this way, where if two people are, if I work on that common section and then someone else can actually work on that common section, we have two different versions. Which one is correct? With GIT, they leave it up to you to decide, but they try to provide a mechanism to help you decide. If we have, say, in Windows, for instance, and I think macOS probably works this way, if I'm copying from one folder to another, and basically I have the same file name, it'll say that file already exists. What do you want to do? And then you can pull for more information and look for things like file size, compare the two, and file date. And that's precisely how GIT handles it. It shows you both versions, and you can pick which version that you want to. You can whole hog pick one or the other, or you can potentially make edits on one or the other, maybe some combination. A third approach Professor Hudson doesn't list for in terms of conflicts. They might not, GIT doesn't handle this, but with Dropbox, Dropbox.com, not Dropbox and D2L, cloud sharing system. I use it myself. I have some files. I have my grocery shopping list in general. At home, I have Dropbox installed. So I edit my shopping list here. But if I screw up and I'm still editing that file in Dropbox, I also have it connected with my phone so I can see it when I'm shopping, but also in my office computer. Sometimes I might think of things I need when I'm in the office. But if I screw up at home and I forgot to close it down, I'm in the office, what happens? How does it handle conflict? Because I have two files I'm making edits. Well, Dropbox actually makes a duplicate, saying there's conflicted copy here, the one that's left open, when I actually have, so it makes duplicates. That's another way of handling things. Quick introduction into GIT. Now, again, the TAs are responsible for going through, here's where you click essentially to get started. However, it wasn't made clear to me until after weekend. I made these notes before the weekend. So I actually started going through and making some practical stuff, but I stopped at a point, and I'll tell you where I stopped and why I stopped. But where I stopped, someone else takes off, so you're not just left hanging. So if the GIT resources, it's a quick overview and just some of the nitty-gritty details to get started to give you a feel that it's not that hard. TAs apparently have gone through it too, but it doesn't hurt to hear some of the stuffs again. And in this case, I don't know if some of the TAs have their own course notes, some do not. You can see the click here, click there of the screenshots that I actually have. Professor Hudson does have a video. Personally, for learning coding, I don't like videos. If it's movement, physical movement, then a video, one movement leads to another is handy, but that's just me. But his video does have what you need, apparently, in terms of the assignment. It also jumps around a bit, and that's the part where I stopped. I'll get to that in a bit. And I have this link many times. He has this link in D2L. Tutorial is also where you get a GIT. Where to get Git? This is the downloads link from Git. IntelliJ has, they have a whole bloody playlist with Git videos, playlist with multiple videos. I didn't have time to go through it, but presumably because it's produced by IntelliJ, that it is correct. The only thing I'll mention is keep one thing in mind is IntelliJ is almost certainly telling you, well, they could be having just a local Git repository, or if they have it online, then they're almost certainly uploading it or pushing it to committing it to the Git server, not the uCalgary Git server. So that's something to keep in mind, because at the end result of this, you're going to have to get your IntelliJ repository to communicate with the uCalgary one. But otherwise, there shouldn't be any errors in here because they made the software IntelliJ. So enable version control, fairly easy. It tells you where to click under main menu, VCS, enable version control, fine. Now, as you make changes, one thing that a version control system does that you don't get from this manual system is it actually tracks it for you and displays information. In a way, it's almost like if you use Word and track changes feature. If I turn it on, as I delete text, it tells me what I deleted and it marks it as deletion. If I insert text, it tells me. If you haven't used change tracking in Word, in a way, it's also this information about changes is like the newsfeed that you have in Facebook. What has changed with your Facebook contacts since the last time you logged in? But similar to the Facebook part of it, this is based on Professor Hudson's advice, and it sounds quite sound, reasonable. IntelliJ does a lot of things behind the scenes. That's one reason why it's powerful, but it's also slow. What he recommends, and seems quite reasonable, is turn off. These are the IntelliJ ones. You don't want notification for these ones. It's like turning off notifications for the friends on social networking. I've got 5% of my friends who produce 95% of the content, and it drowns out everybody else. So after a while, it's stuff I'm not necessarily interested in either, because they're just daily stuff. So what you just want to check is basically he recommends, it seems reasonable, just check the Java code. But what Git does is I've made a backup, basically local backup as an example of the course web page. You can see version to version over time. But Git will tell you what changes have been made, as opposed to me manually comparing these two files. So here's one advantage of a version control system over the manual approach. I said there's advantages. So I am giving you the honest scoop as I see it, as I know. And you can turn this off. Here's how you access it. So you've got that, I'm not sure what that icon stands for. And then you just uncheck everything except the ones for the .java, his recommendation. The web access. Okay, what this is doing right now, that he should have explained as he went through Git, is you're creating a local Git repository, the storage of your versions on your machine. If you're using Git, I assume it's available in the lab, in the CPSC lab. It's only creating it for your CPSC account. Now, to be able to access it, you're putting it on the cloud as opposed to manually exporting, copying your directory onto, say, a portable drive. But this is also required for the assignments. This is the CS Git we're talking about. You need to authenticate here using your uCalgary login. That's not uCalgary account. But when you actually connect your IntelliJ repository with this, there's an extra security step. And this is the part that Professor Hudson didn't get into, but I said, it's a number of steps and he covers already. That's where I stopped. That's one reason, but I'll get to that up to there in a bit. What I'm showing first is the uCalgary Git, how to use it. Beyond this course, you might use the uCalgary Git for your own edification, or just the regular Git, wherever the heck that is, that server. Because there's plenty of people that post their work, not assignment work. Don't do something stupid like that posted publicly, but their work because they're proud of it. They want to showcase it. Or if during an interview, someone says, "Can I see your sample code?" to an employer, that's where you can put it up. And of course, make sure you follow good stuff. It's good coding style, of course. However, for your uCalgary Git, select this as private. That's an important part, very important thing I'll get to. What you do with your non-assignment code on your own, we probably want to make it public, but that's entirely up to you. To be able to access your repository, so I'm logged in here, look under your work, and under your work, we can actually see the repositories. I didn't create very many. I'm just creating it for this help. Adding code. So I'm going to add code. There's the add to files here. And there's a whole bunch of instructions in the UCalgary Git how to do this. Now, in this one, I'm doing the simplest possible case where I'm not connecting the repository, but I'm uploading a class at a time, which can still be used with IntelliJ. Because if you export if you pull all your classes, if you do what I do with my example and you put them in a directory and then you open that directory in IntelliJ, you're okay. So upload the plus, very, very simple, drag and drop. And then I uploaded just as a test one of my previous examples from the structures, example 3, for instance, that shows it there. But I didn't upload it as a repository. I just uploaded that one file. Dead simple to do. Finding your project so you can have the search, and then you can see the git test, and then there's the driver for that example 3. Okay. Now, uploading the Git via IntelliJ. This is more complicated, but it's far better. I said earlier that I'm not sure in what form it'll be uploaded, but I speculated that it should not be uploaded a class at a time for this class, because then you have the issues of IntelliJ having problems where if you just open up a single class at a time, it's going to say that stupid error, class and num not found. You have to open up, you have to create that directory structure. And I said, a few weeks ago, I predicted the intelligent way of doing this, smart way, would be essentially having some mechanism where you export that whole project. And this is exactly what we have here. Upload. This is more complicated, however. Again, his video has apparently the complete steps. And TAs have, at least for, I only had one student respond in this morning's class. And granted that I suspect that that student probably is one of the sharpest ones in the class, my intuitive feeling. But it's based on what they've covered in his tutorial that it was sufficient, the TAs. Now, with that in mind, the average student probably need more, and this is the more. There's many Git videos available, but this is specific to tying in the UCalgary Git. That's an important thing. So how to do this? So you create a Git repository, have it show up and connect these two. You log in with a browser. He's a little bit hazy on this part. He suddenly pulls something up. You don't recognize that it's a browser. You won't know what he's doing. Create a new project there, and that project matches the other project. Create an online project to associate the local one, local on your computer. The properties of the new project is you create the new project. This is UCalgary Git, so I'm still there. We give it a project name. That project name, I had it match the Git repository. I'm not sure what happens if it doesn't match, but to be safe, I had it match exactly, so I copy pasted it. This is now, rather than uploading to UCalgary Git, uploading the general Git server, you're uploading to UCalgary Git. So this is something that's specific here, as opposed to the Git videos you see online. This is important. This part over here, the private explanation. Why did I say this? If you screw up, you really could be called in for academic misconduct. Then you have to explain yourself to the associate dean during investigation. Academic misconduct reminder, and I'm not trying to scare you. I'm just trying to keep you from doing something goofy, getting yourself into trouble inadvertently, is if you include someone else's work and you don't cite it, so you're implying that it's your work. And we're evaluating what you submit, so that's basically cheating. The person who submitted someone else's work. Someone else wrote the report, part of the report, or all the report, or the program. Now, the other part of it is this. If that other work that you got, this is a reminder, it's from another student. This is where the copying is. You copied from someone else, but if there's another student class, they provide you code with university regulations. It's not just this one. This person is also guilty of misconduct, meaning knowingly provide because they're helping you cheat, essentially. So, if you don't set it to private, someone finds it potentially, and it can be found. I haven't tried to search in the UCalgary yet, but I have seen Gits online. Git repository, then if someone else copies it without you knowing, well, the code's at the very least similar, say they copy paste it as is, then you will be also called into the investigation. Whether or not you're found guilty I don't know. I don't do the rulings. That's up to the dean's office. And it has happened where someone has gotten called in. One of my classmates, so I can say I wasn't an instructor, so there wasn't any, I don't have the inside knowledge. He left his Unix directories open. And he has a bunch of neat Unix stuff, and that's perfectly innocent. He loved to play around. He's a pretty sharp guy. And he said to the mailing discussion group, here's some useful Unix stuff. And he had one directory. People poked around to see what he had, but they also noticed this was for CPSC 331. Wait, there's a 331, and we were all classmates. They went into his directory, and the guy unfortunately left his directory wide open, and they just copied his code. So he was also called in the investigation. What happened, I don't know. But I'm certain enough, I mean, he wasn't a friend, but I'm certain enough that this guy wasn't trying to help. And there's about 10% of the class that got called in. He wasn't knowingly trying to help them cheat, but there's an example. So this is an important thing. This is from Professor Hudson, from who's taught the course before and dealt with the TAs. Uncheck this by default, it's checked. What he says in the video, I'll take his word for it, and I would be definitely apt to take it. If you check it, then it's going to cause mutual headaches for your TAs, and you don't want your marker ticked off at you at the very start because they can't access your work properly. So additional steps. Okay, well, I did it a few reasons. I looked through his video, one, to vet his video just to get a feel for, okay, this is a resource. How useful is a resource? Up to this point, okay, I actually made some screen grabs of some other things. I do it by habit, but also so it's a resource for you. I made my own screen grab. I didn't steal his work, so I could actually follow through myself rather than passively doing it. And also, because I had to jump back, he suddenly, oh, here's a step, bang, it's done in a second. So I had to slow down the video. So that's why I made the screen grabs. But there's another reason why here. Additional steps. So I've created this Git repository. How do I connect my local Git to the online Git U Calgary? Well, that's where it's more than just me logging in with my authentication. This was early Monday morning, and I was starting to teach Git version controls Monday morning, so I wanted to get the notes up. It was in the wee hours. But beyond that, also, I started looking. I thought there's quite a few steps. They're not complicated. One, it was late. Two, he suddenly said at this point, this is where he jumps around a bit. He said, okay, here's where you need to actually get a public-private key. And he was going step by step up to this point. And he said, but I'll show you later. This is where having your own notes and following along, making your own screenshots of what you're doing in IntelliJ is handy. It isn't hard to do it, but also because he has it somewhere else, someone else has it. I said, okay, I don't have enough time to go through it because in class we're behind. But I do tell you when this video where he starts working on the rest of the steps here. What you will have to do, I'll give you the theory, but the theory is important, is this ties into to cryptography a little bit. Okay. To help you understand what you're doing, you have to have what's called a public and private key. It's hard to understand in terms of Git, but it's easier to understand, say, email or something else. Email, as you know, by default is not secure. So someone else, if I send it to someone, they can basically intercept it and sniff what they call sniffing the packets, read it, put it together. Now, I can make email encrypted or a file encrypted. And one way they do this with the encryption is having encryption keys. To quickly explain this process, and you need to know a little bit about this, because if you screw up, you could leave yourself wide open. Or if you screw up, it won't work. Someone can't decrypt your work. Or an IntelliJ or the Git repository won't be able to connect properly. So you do need to understand some of the theory. So there's a key and there's an algorithm. To keep it simple, I'll have a bogus algorithm that's not used in real life. Your text that you have in your email can boil down to, say it's asking for simple. It's basically can be converted to a bit pattern, a very long bit pattern, but bit pattern. We want to convert this from plain text, where essentially every 8 bits or whatever can be converted to a character. That's the readable form right now. So we want to encrypt it. To encrypt it, we need an algorithm and a key. Suppose the algorithm is one of the logical operators. It's not in real life because it's dead simple to break the code. But suppose it's logical and or, it doesn't matter which. So we've got our text in a bit pattern. We want to scramble it or make it unreadable. So we apply the AND operation. We have your text here as a bit pattern, but in order to apply AND or, we need another sequence of bits. That is a key. That's actually what's done in real life. And in real life, they say there's 64-bit keys, now it's up to 128. The longer the key, the harder it is to basically decrypt someone else who's trying to break the code. Okay, fine. So we have the key, but we also have to know the algorithm. In this case, the algorithm is, say, I'll pick one, and. Now, the public-private keys, how they come into play. The private keys allow you to encrypt information, and they prove that it's coming from me. I have a unique private key. You have your own unique private key. Consequently, the important thing is it says online, don't share, don't make that private key public. Keep it on your own device and don't lose the damn thing either. Fine. When looking at email or a file, if I send this encrypted email to someone else, well, we have this bit pattern where it's my text, but now we apply the AND operation. It's no longer a readable text. Occasionally, it might be a real ASCII character, but it's not the original one. What they need, essentially, is they need that key that I applied the AND operation to be able to decrypt it. You have to know the algorithm. That essentially, the gist of it, is the public key. The public key allows someone to decrypt the text, but it doesn't allow them to encrypt it, because if they encrypt it, they can impersonate me. The public key only allows them to decrypt messages that I send. So the gist of how this works is the following. With it's got their is you have to get a key, an encryption key for Git IntelliJ, and they should show you how to do this. You keep the private key on your local machine, but the way it's described is on CS-Git, you need CS-Git to have the public key so that these two things can communicate. That's the gist of how it works. There's a few additional steps, but that's what's missing. And I'll leave it to you to look at that video and get the TA explanations. That's what you need to do that push. Once you have that done, then you can click inside IntelliJ. I think the menu option is actually push. And the push, because you have that connection, is basically going to upload it to the UCalgary Git server. Test it, and it basically works on a project basis. So it uploads the changes for that project, not individual classes. So that project is created in its complete form. So you don't have, hopefully you don't have the IntelliJ issues. That's the theory explanation for essentially important theory for the remaining steps. But partly because there's so many steps, partly I don't have time, and partly because he stopped and said, oh, I'll teach it later. Then it's another part of the video. I said, and it was late, and it was, I don't know, like 5 in the morning on Monday morning. I said, heck with it. But you have enough people do it. So the Git information here is the lecture notes of Professor Hudson. It has alternate explanation why I have some details, but I confirmed with him that these Git parts aren't the theory. Essentially, I went through and looked at the theory that was important. I covered that, but he had said that the use of Git in IntelliJ, the click here, click there, you're getting that from tutorials. There's might be an additional set of lecture notes that talk about Git, and it should say this section is called development. The development one, might be another development one. I don't know if he made it publicly available. This is available in D12, but I included it so you don't have to search. One by Steve Sutcliffe. It's essentially this, but Steve Sutcliffe taught this in 233, much like I'm doing now, but he did a pretty good job apparently. He has more detail, good explanations. So that's